Welcome everyone to today's virtual user group. Santosh is going to be presenting on simplifying entity matching with machine learning models and IBI data intelligence. But before he goes into that, I wanted to give a brief update on what we have going on at IBI. My name is Hannah Knox. I am filling in for Shay Bagwell while she is out on maternity leave. You can expect to see her around again very soon. And with that, I want to go ahead and hop into just a couple of quick announcements. Just as an FYI, the chat is off today, but the Q&A is open. So please submit all your questions via the Q&A function. Santosh and Dan and Manju are all here to answer your questions, and we're excited to see what you guys are interested in. You can visit us on the new IBI.com website that did go live in December. It's a fantastic resource that includes all of your education and training resources and access to the support site, upcoming events, and where you can view on-demand webinars after the fact and read customer stories. And we also recently released the new IBI community. So this is an IBI only community. You can find it by going to community.ibi.com. If you were a member of the previous community through the TIBCO community site, you'll be able to reset your password if you remember your username. And then you go to log in, you reset your password, and then you're able to log into the new community. If you were not a member of that community, then you just start from scratch. There are actually already like 10,000 posts there because of all of the content from the prior community was migrated. And then we have a very active base of users already there. So go ahead, check it out after the session, and let us know what you think and what you'd like to see more of there. Summit registration is live. You may have heard us discuss Summit at the last virtual user group, but we are having a mini Summit roadshow this year. We're going to be hitting 4 different cities in the United States. It'll have exclusive looks at the future of the IBI product portfolio, hands-on training and labs. There will be an expert room where you can come with your laptop and show us your questions about your deployment, and you can get access to those IBI experts on site in person right there all day. So these roadshow events will run from 8:30 to 5:30. They'll be totally packed with content about product training, and again, those expert hours are available to you. So the first one is Summit Boston. It is April 11th. Registration did open up today, really. So if you go to our website, ibi.com, go to our events page, and then you can see the in-person events has that registration link open. So go ahead, sign up. Can't wait to see you there, and let us know what you're wanting to see there. Again, this is the ibi.com events page, so you know what you're looking for. It's under the customers tab. You'll see events, and then you can go there and you can click on our in-person events to see more. If you aren't already following us on social media, please go ahead and do so. We are on LinkedIn, we're on X, formerly Twitter, and we are on YouTube as well, producing lots of good content there. And yeah, if there's a specific demo or a specific topic you're wanting to see more demos on, please let us know. We'd love to create more content that you guys are looking for. So yeah, with that, I'm going to go ahead and shift over to Santosh's presentation, and we will go from there. Thank you guys again.
Hello, my name is Santosh, and today I'm representing the IBI Data Intelligence product team on this virtual user group session. Late last year, we launched the IBI Data Intelligence as an integrated data solution, providing end-to-end data management capabilities on a scalable and cloud-ready architecture. Today, I'm pretty excited to show the machine learning capabilities that we extensively use in the IBI Data Intelligence platform for entity matching and entity resolution. The agenda for today, first I will introduce you to some key concepts as it relates to entity resolution and the emerging role of machine learning in that space, followed by live demo. So before we get into the demo, I would like to introduce some of the key concepts in entity resolution. The simplest way to describe entity resolution is that it's a process of identifying duplicates, linking, and resolving them. So let's say you have multiple sources of information. There is always a high probability that data aggregated from these different sources will have records that correspond to the same data entity, i.e. duplicates in a data set. For example, let's take an example of an e-commerce company that collects customer information from various sources, such as uh, different sources such as website registrations, your purchase history, browsing behavior, social media interactions, customer feedback forms, and even loyalty program registrations. And you're collecting that information to personalize user experience. You want to improve, maybe improve customer service or run some targeted marketing campaigns. When you bring together these data sources, you will encounter records with, let's say, similar names, email addresses, or shipping addresses, which might be flagged as potential duplicates. So by identifying and resolving these duplicates, entity resolution enhances overall quality and accuracy of the customer data. This in turn improves the effectiveness of all your campaigns. Maybe it's targeted marketing, so personalized, or you want to deliver personalized user experiences, or you want to improve customer service. There are quite a few approaches to entity resolution. The traditional way of doing things was rules-based, where a predetermined set of conditions is used to identify matching records. Then we have a probabilistic, a slightly complex fuzzy matching way of doing things, where different similarity algorithms are used to determine the probability, i.e. the likelihood that more than one of these records in your data set are matching with each other. And then there's this latest trend in the industry where we use machine learning models. And these models learn from your data, from the data patterns and similarities, and use that learning to predict matches. Now let's take a role of entity resolution in master data management. What does it do for us in the context of master data? Entity resolution enhances the overall quality and accuracy of the master data. By linking and merging similar records, you can achieve a unified and holistic view of data, which leads to deeper insights and better decisions. Also, by implementing a systematic way of linking, identifying, linking, resolving these duplicate records, you will achieve higher levels of automation and operational efficiency. By improving the accuracy of your data, entity resolution also supports your data governance policy. It also serves as your single source of truth for other initiatives, data initiatives like advanced analytics, predictive modeling, or even other machine learning initiatives that you may have. Why use machine learning models for match prediction? There are certain advantages of using a machine learning approach in the context of entity resolution. First, the training and deployment process is much faster and intuitive compared to the manual effort you would spend identifying different match scenarios and defining complex matching and scoring algorithms. Second, machine learning models tend to scale well, especially when you have extremely large data sets or very complex data models. You'll also achieve higher accuracy than traditional models. We have seen that. We have seen higher levels of precision than the models that are built using rules, which are also limited by the kind of thresholds that you're using to do match prediction. There are three kinds of models that we have seen in use. One is supervised learning, where I will be providing the training data set along with a set of match labels, and the machine will learn patterns to make predictions. The second one is the unsupervised learning, where machine discovers patterns on its own. And then we have this hybrid approach called semi-supervised learning, where we do a bit of both. Ours is a semi-supervised model, and it provides better accuracy than unsupervised methods, while requiring fewer labeled examples than supervised methods. So we're trying to strike a nice little balance between accuracy and reliability. So what are we going to show in the demo today? In our demo today, we have 4 phases. We'll start with the MDM Design Time Studio. That's where I'll show you the definition of a customer data entity. Then I'll switch over to the configuration page. That's the part of master data management, IBI data intelligence. And it's an UI where we will see how the machine learning project is configured for that data entity, for that customer data entity. Then we will turn on active learning for that model. So then we'll go to a learn UI, we'll navigate to a learn UI, where we'll upload a training data set and go through the labeling process to train the model. And when we are satisfied with the model's performance, we'll come back to the MDM user interface, we'll deploy, and we'll operationalize the model, run a search to show how that model is predicting matches. So I'll turn off my camera now and put on the demo hat and switch over to that. See you on the other side. Step 1 of this flow would be to define the data model. As you can see, I have opened the MDM Studio, and I already have a project called Bootcamp. This is one of those projects that we ship out of the box with the product. In this project, we have a data model. What data model consists of is one or more data entities. Some of these entities have parent-child relationships or peer-to-peer relationships. What I'm showing here is a model that has customer, account, and orders. Customer is a data entity that represents customer data, and it has a child entity that captures non-primary phone numbers for that customer. It's called customer other phone. Then we have account that represents one or more customer accounts, and we have the order data entity that represents orders placed by the customer that is billed against the customer's account. In the customer data entity, you can see a list of attributes. And most importantly, for the purpose of this exercise, there is an attribute property called match. Whenever that property is enabled, we are telling the system that this attribute is going to participate in the entity resolution process. I don't want to spend a lot of time here with modeling all of these design time user interactions are well documented, and our focus of our discussion is to show you the learn UI. So I will just jump from here and show you when this model is deployed in the MDM server of IBI Data Intelligence, how it shows up on the UI, the repositories that are created, and how to configure the ML-based match prediction model. Now that we have deployed the model, I can come into the IBI Data Intelligence homepage and navigate to the MDM, which is right here, this application called Master and Govern, and go into the deployed master data repositories to view which repositories have been created. In our model, I showed you these are the 4 data entities we have. The one that we are going to use for our matching process is the customer data entity, and it includes all the attributes that we showed you in the, or that I showed you in the design time view in Studio. The next thing we are going to do is show you where the AI matching is configured. we have already configured this project called Standard Customer. This is a AI-based matching model that is configured with the primary repository called Customer. As you can see, this is an active project that's already deployed. And the reason we did it is to show you how the different versions are tracked within the system. You can see there are previously deployed versions, version 2, version 3, and the currently deployed or active version, which is version 4. You can see the different metrics associated with the model performance, like the error rate. You can also compare the models. But before you go back to retraining or training this model the first time, you'll have to come to this screen and click on Edit, confirm that you are starting your edit process. And that's it. We'll come back to this page once we have completed the learning process. And then we'll complete the edit. We'll deploy that project and use the same match prediction model to browse and search some data and show you how the model works when it's trying to find matches against data that's in the repository. Well, now we are in the third phase of our process, which is the training phase. As you can see, I have the same ML match prediction project that is associated with our customer data entity. I've already uploaded a sample data set or a training data set that consists of the data that I want to use for training this model, and has all the fields that I want to participate in this match prediction model. Because we have a semi-supervised approach, we also allow users to select the features that that you want to train your model on, rather than using unsupervised approach where the system discovers the features on its own. And the good part about that is you could create different types of features. We have generic features like date, cognate, and simple. And then we have some data specific features like this one, which compares first name, last name, and an optional middle name, and uses the person name feature to do that comparison. Here we have a date type, which is a generic type that compares two date values. You have the option to also select match empty values, which tells the system that if you find empty date values in a pair of records, instead of giving it an empty value penalty of negative 1.0, consider it as a good match, which is a match of provided a match score of 1.0. Then we have something that is unique. It's called cognate, and the cognate feature is really valuable when you are comparing related fields. In this example, you have address, line, city, state, and postal. And this accommodates all those scenarios where field values may have been mismapped. For example, city may be mapped into state and state may be mapped into another field. So what this does is tells the system when you are comparing, you should also compare the values across these fields. Similarly, you can also set up a non-cognate weight, as in if you actually discover fields that have matching values um, in different fields, then you can add a penalty score, and the penalty score will be based on what you set up in this particular property. Then once you have defined all your features, you're ready to start training. You've told the system that these are the features I want to use to train the model, and I'm ready to start doing pair selection. In this pair selection, you're asking the system to provide you a pair of records. So I'm going to go click on Suggest Pairs. It will show me a pair of records, and based on the attribute values, I have to make a decision. I have to say, do I think these two records are a match? If I do think they're a match, I select on true. If they're not a match, I select false. If I can't make a decision, I click on unsure. For this one, I'll go with false. I save this pair. Another one that I think is not a match. Here's a good example where the first name and last name are probably swapped, and the date of birth is pretty close for me to think, given all the other fields, that this may be a match. So I'm going to go ahead and select true. And I can do it as long as I'm satisfied with this training session. So once I'm done, I can ask the system to stop suggesting, and I'll do this last pair. As I save this pair, I have provided all the labels that I want the system to use to train the model. You can go into the training tab and ask the system to run training. Nice. So one of the other things is when you run the training and I have the new model, I can go and say, save the model, and also provide me a set of suggestions. What you can see here is maybe there are pairs of records that have too few false labels. You want to look at only those records, or you want to look at records that have no pairs or possibly mislabeled. So you could do all of these. You could take this suggestion and do a targeted review of these records. You can probably relabel these records. On the other side, you can also look at all those pairs of records that are contributing to false positives or false negatives. For example, if I click on false negatives, shows me which pair of records that I've labeled is contributing to that. I can remove it from my training data set. Once I remove it, let's do a couple of those false positives. Delete this, and I can go back and start training it. Now you can see once I have trained it, my error rate is 0, false positive. All of these numbers are pretty good right now. So I can go save this model and I'm done. I can then deploy this model and activate it on the MDM UI. The other thing that you could do is at this stage, if you're not satisfied, you can come back here, restart the training process, relabel, go through this process until you find the set of performance metrics that you're aiming for. So with that, I will switch back to the MDM UI and enable this new model. Remember the match prediction, the error rate is 0 because the one that we have already in place, the version 4, is at 6%. Okay, we are in the last step of this process, which is complete the edits, deploy this model, activate the model. So remember the screen where we went ahead and said, I want to start editing the model. Now that I have completed the training session, save that model, come back, say complete edit, go to the selected project. And as you can see, this is the new model. Compared to the previous one, the rate has dropped to 0%. Go ahead and approve this model and we deploy. And just like that, version 5 is active. And just to show you how this model is put into action, I'm going to do something called browse search. This is basically mimicking if you have a new data record that shows up and you want to use that model to compare the records that are in the repository and do a match against the records in that repository. This is pretty much mimicking that same concept. So here, got a record, use these two fields. And first pass, I'm not going to use the model. So you can see I've disabled this option. I'm just going to do a fuzzy match. I find one record with a similarity score of 0.86. Once I enable that project that I just deployed, or the model that I just deployed, I can start seeing a lot more records. You can see first name and last name, first name and middle name are slightly different. You can see a lot more records coming up in our search results. With that, I conclude my demonstration on how to use or how to train machine learning models, how to deploy them, to activate them, and use it against one or more of your data entities deployed in MDM. There was a lot of nice features that are both in the Learn UI, the Design Time Studio that I couldn't cover in detail. However, if you have any particular issues or concerns or questions related to this process or any of these features, either you can refer to our MDM and patents user guide that's part of the data intelligence platform, or you can absolutely reach us on the community. We have a new community, IBI community, live up and running. I post this video on that community as well. All right, I have turned my camera on. Hope you enjoyed the demo. With that, I'll conclude this session, and I'll be watching out on the Q&A to answer any questions you may have. And thank you for your time. Back to you, Hannah.
All right, that was great. Thank you so much, Santosh. Let's see if we have any questions that we want to go into. And I see it looks like Georgie Yanev raised their hand. Do you mind dropping in your questions? I see a few other raised hands now. Do you guys mind dropping your questions in the Q&A box? Thank you so much. Okay, it looks like we have a question that's coming in. Can you tell us more about the model, i.e. the algorithm? Is it a random forest, gradient booster, or what specifically?
Actually, that's a proprietary algorithm. It shares some roots with the current crop of deep learning algorithms, but it's distinct from them, and it's an algorithm that's targeted at detecting duplicates in data records and searching data records, whereas the current other deep learning models are more general and less targeted.
Great, thank you. All right, well, I'm going to just have another callback to the Boston Summit event that's coming up with registration having opened this week. If you guys haven't already checked it out on the website.
We have a question. Sorry to interrupt.
Great, no, you're good. Go ahead.
Dan, there's a question that came up. Does this model work well on numeric data?
Yes, it can work with numeric data. The APIs tend to be built around record-based data, but internally the model can work just with vectors of numerics.
Right, we'll allow just a couple more minutes for questions that are still coming in. And as a reminder, after the session, you will get a prompt to answer a survey about the content for the session. Please fill it out. Those responses are very, very helpful for us in planning out our future events. And you will receive a copy of the recording of this session by mid next week. And you can find the recording also on the IBI community, as well as other content surrounding the data intelligence product and IBI patterns as well. All right, well, if there are no more questions, then we will end a bit early today. Thank you so much, Santosh, for your presentation. That was very informative and exciting to see what we can do there. Thank you. And thank you to everyone for coming today.